Thank you again, everyone, for joining us for our community session today. As you might know, we have multiple chapters in our community that we run worldwide. We have about 142 chapters running right now. As and when we get more speakers to join, we have more communities opening in different parts of the world. We keep expanding. So if you absolutely are keen on starting a user group, would like to be an organization that supports us, please let us know. We have some special gifts for you. Here we have a few scan codes for you to have a look at. You can chat with our teams. At the Slack workplace, we have our essays, we have our internal subject matter experts who can answer your questions. You can see different trainings that we run, short snippets on YouTube, as well as we have the technical forums, which we have at discuss.elastic. You can come and post a question there. You can start a conversation, and our subject matter experts will help you over there as well. And if you'd like to join our community at APJ, please scan the barcode on the corner. One exciting news that we have, if you're not aware, for the last year, we have been running a program called Elastic Contributor Program. So any contributions you make towards our code, any presentations that you do for us, when you come and speak at any of our conferences, you organize events for us, we have great prizes, we have swag. We have also a training subscription that we give out annually. So please join the contributor program. If you need any help, please shout out. And yes, the exciting bit when we are hiring in the ANZ region, if any of you are keen on any of these roles, please hop on to our elastic.co page. And at the bottom, there is the hiring section where you'll be able to apply for these positions. And use a free cloud trial if you are keen on getting started. Perhaps after the session, you can apply the knowledge that you've learned today. And I would like to introduce very happily Michael Hyatt, who's our Principal Solutions Architect at Elastic, and Pas, who's the Solutions Engineer at Snyk. Unfortunately, we lost him to Snyk. He used to work at Elastic before. So he's a great champion, and they will together take you through observing and protecting applications today. Thank you. And if you're keen on speaking at our events, please write to me at meetup@elastic.com. Thank you.
All right, so I'm sharing my screen now. So this is us, that's me and Paz. Very nice to meet you all. And today we're going to be basically demonstrating and showing the integration between Snyk and Elastic. It's going to be a virtual meetup, as we all probably all aware. Over to you, Paz. This part is yours.
Cool. Thanks for coming, everyone. I know it's the middle of a workday, but we really appreciate it. So what I'm going to do is I'm just going to start describing the Snyk platform, and Michael will then talk a little bit about Elastic, and then we'll show how we come together to be able to troubleshoot an issue that's occurring in a Kubernetes application, and how Snyk can not only feed data in to the Elastic platform, but also be used to actually fix a vulnerability as we roll out a change to an application live in production. So just a little bit about the Snyk platform. So it's an app security platform, and we have 4 products as part of that platform, but our aim is really around empowering developers to take control of security from 4 different points here. So the first one I'm going to talk about is open source. That's your open source dependencies that you're dragging into your projects. I'm also going to talk about infrastructure as code, as to when you're stamping out infrastructure, we can test the security configuration of that for unknown vulnerabilities or entry points. I'm also going to talk about Snyk code as well, how we can test your actual IP, your code that you're writing in your application versus the open source dependencies. And then if you're packaging applications and running containers, we can scan those as well. So next slide, Michael. So if you look at the modern application risk profile, it's really 4 pillars, and it's exactly what Snyk's doing, right? So that code that you're writing may only be 10 to 20% of what makes up your application. Let's say it's an API or a web application. So we're able to scan that, and versus something that may scan in hours, we're able to scan that really, really quickly so the developers can scan that even before they're committing their code and start looking for vulnerabilities in the code that they've introduced themselves. Next is open source as well. I mean, if you're building anything out there in terms of code, you don't really want to write low-level plumbing sort of code. So you're relying on the open source community and dependencies to drag those into your project so that you write less code and just benefit from what the community has already written. But as a result of that, you're also open to vulnerabilities, not only in those dependencies, but also the indirect dependencies that are dragged in from those. So we can test those. Again, I spoke about once you've got your application, you build an artifact from your application, you probably want to run it in a container so we can test that application and the vulnerabilities that could be introduced through the base image of that container as well. So we're talking about Linux vulnerabilities here. And then infrastructure as code. So if you're building containers, you're more than likely probably running it on Kubernetes. And even if you're not, you're using IAC to potentially, create some configuration on AWS, for example. And so we can scan that as well, looking for vulnerabilities in terms of what you need to be concerned about. And you'll see that in some of the demo that we're talking about today. So next slide. Thanks, Michael. So let's just visually have a look at the platform. So click next, Michael. Sorry, this is a build out slide. So the Snyk platform is all around finding, fixing, preventing and monitoring, as well as managing vulnerabilities across the whole software development lifecycle. From the developer in an IDE to container registries to all the way in Kubernetes to CI, CD, capability from a CLI to an API, we're empowering developers to test right across the whole software development lifecycle. So how do we do that? Just click next, Michael. So first is that Snyk open source. Like I said, you'll be dragging in open source dependencies through a package manifest file, depending on the programming language. So in Java, that could be a pom.xml or a Gradle file. In Node.js, it could be a package.json. And then when you're integrating through your IDE or potentially through source code management, just click next, Michael. You're going to be able to run a Snyk test from the CLI or through Snyk app itself. And again, I'm going to show you in that demo itself to be able to run a test there. Next. And the next evolution is a container. You're creating an artifact. You want to put that in a container so we can test, running container tests in container registries as well as in Kubernetes as well at runtime. So just click next on that. So that's going to allow you to run a Snyk container test, whether it's in a local Docker daemon or in a container registry. We allow you to do that, as well as scanning a Docker file as well, right? That may be in your source code management system as well. So next, Michael. Snyk IAC is exactly around what are you paving in terms of what your infrastructure as code file looks like. So that could be Terraform, that could be Kubernetes YAMLs, that could be CloudFormation. And we've just recently announced support for ARM templates as well. And so the ability to be able to test that configuration so that you can be confident that what you're deploying is as secure as possible and doesn't leave you vulnerable. So we do a Snyk IAC test, or we can use Snyk app, the UI as well. And last but not least, Michael, just click through twice there. So here we're actually testing your custom code. So whether you're writing Java code, JavaScript, C#, and we're introducing new languages. There's a few beta ones at the moment, such as Ruby and PHP, allowing you to actually test that code. Are you writing code that's bringing in vulnerabilities as well? So that's holistically the whole Snyk platform in terms of how we test through the whole software development lifecycle. So if you click next, Michael. You just want to build this one out just once, twice, all the way, one more and one more. So here I'm just giving you a feel for what you'll get in the UI depending on what you're scanning. So when you're doing an open source scan, there's an example of a requirements.txt file. We're scanning that and presenting all the vulnerabilities, how you would fix that, what the remediation paths are, what the CWE is, what the CVE is, all that sort of stuff to be able to understand fully and appreciate what vulnerabilities you're dragging in from these open source dependencies. The next one is actually testing so under Snyk container is actually showing you a GUI of what it looks like to actually test a container sitting in a registry directly and how we can auto remediate a more appropriate base image if required. Snyk IAC test, we're testing the configuration file, and Snyk code, we're testing the code, and we're giving you data flow and analysis of how you could fix your code based on what's happening in terms of what we see as fixes in the wild that would be appropriate and relevant and need fixing. So again, next slide, Michael. So one of the key pillars of our platform is the ability to not only provide automated remediation, but also enable a fixed pull request, whether that's manually or it can be automated through the platform. So it's all good and well to announce a vulnerability, but the other thing that our customers appreciate is the ability for us to fix that vulnerability so that then the developer can run his checks and merge that fix at the appropriate time. So we're just making the developers more proactive, not only identifying where the issue is, how it can be fixed, but also giving you the ability to fix it through a PR request or potentially automate it through the integration with whatever Git SCM that you may be using. And so that's what we call our single-click fix pull request. And we're going to do that in today's demonstration. So next, Michael. I think it's over to you now.
All right. Okay. So, we're going to use Elastic in sort of collaboration with the Snyk platform, but just for those of you who don't know what Elastic is, which I can't imagine there's going to be many of you, we're talking here about Elasticsearch Kibana and the layer of beats and Logstash ingesting the data. We've got the three solutions that we've built on top of our stack, which is Elastic Observability, Elastic Security, and Elastic Enterprise Search. The platform is going to be hosted can be hosted in Elastic Cloud Enterprise, can be run on Kubernetes or run as self-managed stack. Today, we're going to use Elastic Cloud, which is always, I call it the easy button of our stack. So it's kind of Elastic Stack as a service running in Elastic Cloud. I don't think I'm going to be dwelling too much on this slide. I think this is where, this one's yours. Actually, no. Maybe I'll talk about sort of something that we found. Something came across my sort of in my mailbox as a collaboration. So Snyk is an Elastic customer, so it's quite interesting to see that Snyk is using Elasticsearch, the full text search capabilities to search in the reports. So that was quite interesting to find another point of contact, another synergy between the Elastic Stack and Snyk. I think it's one of the developers at Snyk, wrote that blog post. Now, today we're going to be using FileBit, and FileBit, as you probably know, is a lightweight data shipper written in Go. So we're going to run FileBit, and essentially FileBit is like a tail-f that you can run, and it can help basically stream your log files into Elastic Stack. So, with logs UI, it acts almost as tail-f on steroids, which means tailing all your log files across your entire infrastructure. It accepts a variety of inputs, so it can take ingest log files, take standard inputs, containers, can read Kafka messages, Redis messages. Can accept, for example, communications over TCP or UDP, such as syslog, can connect to S3 buckets. So it's pretty versatile and lightweight data collection agent. It supports a single output, so you can send your data either to Elasticsearch or Files or Kafka, and a whole bunch of other technologies. It can also send data to Elastic Cloud, so it's very easy to kind of point it at the cloud. The first time it runs, it can initialize your cluster with mappings and index templates and ingest pipelines, and then subsequently you can just start shipping data, and the data will be parsed and will land in the Elasticsearch cluster. Another interesting sort of relevant tidbit for today is starting from Elastic Security 7.11, and we're now at 7.15.2. So for quite some time, we support the ingestion of vulnerabilities data reported by Snyk, and we're using FileBit module for that. And it enables identification and potential exposure of your code base and the containers that you're using to various vulnerabilities discovered. So this was a snippet from the 7.11 announcement of Elastic Stack. So FileBit uses modules. So it's got this configurable, pluggable modules that can parse certain log formats or data formats. So it typically is supplied with a bit of configuration. It can install specific ingest unknown pipelines. Can create its own Elasticsearch mappings. It can even build your own or create its own Kibana dashboards, machine learning jobs. There is close to, I think, over 100 of FileBit modules for a whole range of technology. And today we're going to be using the Snyk module. So FileBit has a specific module that is capable of ingesting data from Snyk platform. So obviously you need to configure it with credentials pointed at the Snyk platform. So we'll tell what pieces of data it needs to ingest and send into Elasticstack, and you should be done. That's all it really takes. I think these are all the slides. So we're off to a demo. So all right, so let's talk about the setup first. So in today's demo setup, we've got an application that consists of the application layer component written in JavaScript. It's a Node.js application that connects to MongoDB. So MongoDB is running in Google Kubernetes engine. So it's running in Google Cloud. It's a Kubernetes cluster that's running the application, and it's got a FileBit that basically collecting log files from that application and sending them to Elasticstack. And it also, there's an instance of FileBit that is configured with FileBit module that connects to the Snyk platform that, obviously scans the GitHub repository, scans the container registry that is used to deploy these Kubernetes pods, and then sends the information, all the information sends the logs, metrics, APM, FileBit sends the logs data, but there's other components of the stack that send other bits of data to Elasticstack, and the Snyk module and FileBit connects to the platform and sends the vulnerability data into Elasticstack as well. And we're using the Elasticstack running in Elastic Cloud, and we're using the observability solution built on Elasticstack.
Cool. So as part of what I'm going to demo, I'm going to show what we call an SCA scan, so Snyk open source, and the specific application that we're going to be monitoring here is running in a container on Kubernetes. And as Michael showed you, that Kubernetes cluster has FileBit running in there to grab all the data in terms of what's happening in that Kubernetes cluster. But at the same time, I'm going to be running a FileBit module that actually pulls the data out of the Snyk platform that I'm going to show you in the Snyk UI and send it to the Elasticstack as well, right? And that's going to help from a monitoring perspective on the Kubernetes side. So we'll get to this in the demo. Let's go past this.
I think if you want to take over the sharing, I think you should be able to.
Okay, cool.
Yeah, override me, and then we'll come back and talk about the discovery.
Yeah, cool. No dramas. So I just need you to stop sharing, and then I can...
Yeah, should be able to take over. Hang on, stop sharing. Yeah.
Cool. It's just a little bit about the Snyk. I'll just make this a little bigger. So here I am. Here's some data in that we were talking about that's available in Snyk. I've imported various different repos from my source code management system. In this case, I'm using GitHub. But of course, we support all the different types of Git SCM source code management systems you can think of that are out there. And the project that we're working on today is called this vulnerable node app itself. But I did talk a little bit about how Snyk and app security is all around empowering developers to be able to run tests through the whole software development lifecycle. And what enables that is what we've got through our integrations. And so on the integrations page here, you'll see that we can connect to different source code management system. We can connect to all those container registries. We can also connect to Kubernetes and then run testing continuous integration. So you can start to now get a feel on also IDE plugins that the developers can do stuff from shifting left in the IDEs to in their pipelines to run tests to scanning containers that are built and then scanning in the registry to even scanning them when they're running in Kubernetes as well. So let's now go back to this project here. And what I'm going to do is we're going to be focusing on this vulnerable node app, which is conveniently called that for a reason. That's why there's so many vulnerabilities. But what we're going to be looking at is, and you'll see here the various different projects that you see here. We've been able to do a Snyk code scan on the Node.js. We've looked at the Docker file as well and provided remediation across that as well. We've got the Kubernetes YAMLs file here, so we can also do a Snyk IAC test there and look for misconfigurations. But what we're going to focus on here is this package.json here. And so this has all the vulnerabilities around what is inside that package.json in terms of what we've declared as open source libraries and versions that we want to use. And then they're all conveniently displayed here for us. And then, as I mentioned, our customers use the capability of fixing the vulnerabilities by just clicking this button, which we're going to do. But before we do that, let's just go to, Michael spoke about the Snyk module itself. So I'll just make that a little bigger. So again, it's really easy to set up any module on Elastic. So you just go into, and I'm going to take you really quickly here. Oops, that's the wrong one. How's that? Is that big enough, Michael? Is that viewable?
Yeah, that's good. Yeah, that's good.
Cool. So I've got FileBeat running at the moment, and I've got this. I'm actually using the Snyk Elastic module itself, and it's just constantly feeding data into Elastic. I've set it up to just feed data into Elastic from a Snyk perspective hourly, but that's configurable in terms of what would be the best approach. But what Snyk has is an API. That API endpoint is what enables Elastic to write a module so they can get the data out of the Snyk platform and put it into the Elastic stack itself. And so this is where I'm going to show you in terms of this running. And what we do here is we configure filebeat.yaml. I'm not going to be able to open these files. It's got some sensitive data, but that's where we configure the connection to the Elastic Cloud instance. But if I go into modules, and you'll see here I've enabled this Snyk module. You'll see it's not disabled. And in there, I set up the configuration to Snyk. I use the Snyk token to provide access to be able to then call into the API to get the vulnerability data into Elastic. And then I can set various different settings in terms of what I would like. You know, which organizations do I want to monitor for vulnerabilities and get that data into Elastic, as well as potentially I may only want to look at, you know, Java and Node.js applications only, for example, or I may not want to do any container scanning vulnerability data and moving it into Elastic. So you get that flexibility. I've turned it on to just bring everything into the Elastic stack. Okay, so now that's that and that's running. I'm just going to go back to here and just show you here. The data is feeding through. So actually what I might do is just go to DevTool here. So we're using the FileBeat module. So I'm just running a little query here. And there's an every time any data is coming from the Snyk module, it's actually set as event.module is set to Snyk. So I can just run a query on that and start just seeing all that data. I'm only getting a bit of data, but that's coming through the Snyk platform into the Elastic cluster, and it's sitting in this FileBeat index that you can see here. And then if we were to run something not overly complicated, but some sort of aggregation to kind of see how many different vulnerabilities we have from a severity perspective, of course, you can do far more than this in Elastic and run some really, really interesting queries across the data. But if I did something like that, you can start to see that we have 491 critical issues, 2,495 high issues. Just remember, though, as we're scanning the data from Snyk and bringing it into the Elastic platform, we're creating multiple records here over time, right? But anyway, it's been running for a couple of hours now, so I've got a little bit of data in here at the moment. So I think it's over to, is there anything else that I was going to show? Yes, I'm just going to show quickly here. You can see here I've used Lens as part of Elastic here just to create some basic visualizations. And you can see here some of that data is coming through. I'm seeing some of the vulnerabilities by the different languages. So you can see there's Java projects, Ruby projects, JS projects. Linux is actually vulnerabilities that are container vulnerabilities that are containers that are in a registry. And I've started to, Lens is really cool. I can create some really cool visualizations where I can look at related projects and what's happening in there. So I've created a pie chart as well. Very similar to what I ran in DevTools there, just looking at medium, high, low, and critical issues and then breaking that up by percentage. But of course, if you're familiar with Elastic, there's no limit to what you can do with Kibana and Lens in terms of just having the data there gives you the platform to be able to do what you need to do. And the cool thing is the Snyk module that's part of Elastic is getting all that data in there for you. You can start working with it right away. Instead of having to massage it, that's all done as part of the module itself. So I'm going to now stop sharing, Michael. I'm going to switch to you. So,
Yeah, let me share my screen. Almost there. So in this particular case, we're getting a notification basically about a vulnerability. So we're going to take you through the scenario of how we're getting basically, first of all, Snyk platform informs us that there's been a vulnerability discovered in our code, right? To which we kind of want to see, well, what it is about, right? And there's a convenient, I think, button that says learn about this type of vulnerability that we can press, which will take us to the screen that will describe the vulnerability. And in this particular case, we're going to demonstrate how we deal and how we tackle the directory traversal vulnerability, right? Now, remember, we discovered so this is our application that's monitored by Elastic Stack. So we're collecting logs, metrics, APM traces, measuring the uptime. So, all the good stuff that the Elastic platform provides us. But in addition to that, so we're getting new information potentially raised to us as an alert in the platform, in the Elastic platform, or communicated to us through a digest email in Snyk. We discovered this vulnerability. There's a risk of directory traversals in one of our sort of Node.js applications that runs on Apache. And we want to go and actually have a look at, now we found out about this traversal, but was it a 0-day that has been exploited for a number of maybe days and months in our environment that we didn't know about? And now they're basically Snyk now informing us that there's something potentially going on in your environment. So we have the ability, because we were collecting logs and retaining logs in Elastic Stack with searchable snapshots, and the frozen tier has the ability to allow us basically to retain a lot of logs, right? So we can say, hey, give me logs for the last 90 days, right? And you can see, search. This is the benefit of search engine. Like, it just quickly says, hey, here are the logs for the last 90 days. So we can start basically constructing our search expressions that can actually go back and look whether a certain vulnerability was exploited. Now, as part of this particular vulnerability, directory traversals are characterized by using HTML escaped, dots, and some of the sensitive sort of when this vulnerability was discovered. So ability to escape or HTML escape a, sort of backwards lookup. All right, so now we have the 90 days worth of, we can start basically filtering the data in Elastic and see whether was this particular vulnerability exploited at any time. So we can start searching. So we're interested in Apache logs. So we can say event.dataset, right, is, and you can see how basically the autocomplete Elastic Stack, because these fields are indexed as keywords, it's quite quickly, Elastic can actually tell us what values are available, okay? So we can start looking at our Apache logs. Let's put that at the end first. Click enter. All right, so quickly, we're actually able to see that there's quite a bit of Apache logging happening. Now in Kibana query, we can easily combine keyword-based search with a text-based search, and we can say, give us, and also look for URL.original.text. We've got the URL original indexed as text, which means we can just simply do text search within that field. And we can say, my search history, or Kibana remembers what I searched. So this is the expression I was looking for it. Now I can see that there were some searches, or there were some requests sent to my Apache web server that contained escape dot character, which is kind of, okay, that can potentially be something I want to have a look at, because, with the last 3 months, I had occurrences where there's been potentially a directory traversal in my environment. So I can say, hey, let's have a closer look. Let's have a closer look at, for example, and this is where I can see the entire data, well, a sample, entire document being parsed, and I can start adding fields to my view. I can say, well, what do I have here? Okay, so let's, so HTTP request. So HTTP response status codes. Let's see, any successful traversals will be obviously 200s. So we'd want to see those and maybe methods. Okay, we want to see URL, URL.original. So we want to see which ones Google got traversed and which ones were the paths that they were looking to exploit. So I can see a whole mix here of, traversals that kind of start painting the picture. All right, this is a nice textual view and very quick way of actually, well, discovering something that was exploited in your environment. So, remember, Snyk basically discovered this vulnerability that's been out there for quite some time. Now, we've been collecting logs and aggregating and keeping the logs in Elasticsearch, so we can always use this information and go back and search for potential, for potential occurrences or potential events where this vulnerability was exploited and attempted to be exploited. We can even see who might have exploited this particular vulnerability, because if we should be also collecting, say, things like source IP addresses. So we can scroll down to source IPs, and we can see which IP addresses were. Sorry, this wasn't filtering. I'll just add the column and get rid of the filter. But I can quickly see the IP addresses that were trying to, exploit that particular newly discovered vulnerability. So we can go back and say, well, was there a dweller in that network? Well, that's good. Now, how can we, hey, we need to report, we need to try and visualize it. So what I'm going to do is I'm going to go and try and visualize that particular data differently, right? This is where we see records. But let's see, can we visualize it in some sort of a different way? So we can go to our to the visualize library. We can create a new visualization. So lens. So Paz was doing a lot of lens when he built this visualization, visualizing Snyk sort of vulnerability data. I'm going to use lens to visualize logging events over the last 90 days. In this case, we're going to look at how much this vulnerability was exploited. So I can see my filtering expression got carried forward. So I'm looking through Apache.access dataset, and I'm doing a text search within URL original text to see whether someone was trying to exploit that particular vulnerability. I will from the roles perspective, I want to visualize it as a table again, or we can do it as a bar chart. So let's create a table, and by simply dragging the fields, I can say, hey, make the first row the timestamp. So this is going to be my date, all right? And in the metrics, I'm going to put a count of records that says, hey, this is basically the breakdown of days and how many records of this that match this particular search expressions we had within in our environment. Now, let's look at source IPs. We can just search, right? Search for the fields that are interested, that we're interested in. So I can add a row for source IPs. So now we get these records basically broken down by dates and broken down by source IPs. I'll just swap them around because I want the dates to be first. So now we're getting a more condensed view. So we're getting a timestamp per day and top value, and we're not showing zeros. So we can see which IP addresses are suspected or were involved in exploiting this particular vulnerability. Now I want to see whether they were successful or not, so I can go and add the status code. So I've got HTTP response status code. I'm going to go and add to the list of rows. So you can see now the breakdown of 200s and 400s. On this particular case, I may actually fix the value format. So to be top values rather than, and just 3 values should do. should be sufficient. Source IP, I think there could be more, so not just top 3. Let's get top 6, for example. And now we're starting to see basically the table. So this is something that we can go and embed into our visualizations to see what is actually happening. We're not so much interested to see the 400s. 400s are the vulnerability exploitation, or the attempt to exploit that vulnerability failed because our service said 404. So we actually want to see which ones, how many of them were successful. So we want to see only the 200. So we can just go and add a filter. So here we go. We've got a list of our IP addresses that exploited this particular vulnerability over the last 90 days. And it's super simple, right? So you notify. Remember, we just got notified, and everyone's like, "Oh, what is going on? Has this vulnerability been exploited?" And if you're sort of accumulating your telemetry, you're keeping your logs, you're keeping your telemetry data, you can easily go back and see, how much of an exposure or how much you're dealing with. So if you close that breach, are there any? So what's your remediation activity should be, right? So post this activity, we need to go on a big threat hunting sort of expedition to see whether there's additional traces of, whether there's additional damage that the attacker may have done because they successfully exploited that vulnerability. That was a 0-day vulnerability at that time, because this was before Snyk notified us about this particular vulnerability. So yeah, and then the IP addresses, we may want to look into them, basically where they're coming from, what the reputation and so on. Or maybe we need to go on, close our firewalls to those particular IP addresses and so on and so forth. So, having your telemetry available in Elastic is going to drive you down the path, the correct remediation path when Snyk's going to tell you about the problem in your environment. And hopefully this demonstration actually shows us. So over to you, Paz. We now will try and go ahead and before we do that, let me show you another part of the observability stack. I just want to show you that we can actually use the same search expression. So I can just take that search expression, go into my logs UI as part of my observability solution. So I'll go into logs. Leave that alone. These are all the logs that are being collected in my environment. Again, this is the benefit of using a search technology for observability, because it's easy to search for things, right? So we can start searching for logs, or maybe stream them live. Let's try and stream them live. So I've got none. Now I'm going to go and trigger and try and trigger some of those vulnerabilities just to demonstrate that we're actually successfully exploiting that vulnerability using curl, right? That gives us the view of the directory. Hopefully now in logs UI, we're actually starting to see three lines that's saying, hey, you're successfully exploiting this vulnerability. So, and the data got immediately captured. So this is live data basically coming from our applications. So we're not just ingesting Snyk notifications using FileBit, but we're also ingesting application logs and Apache web server logs using FileBit. So now we're seeing basically my 3 curl commands cause the website or web server generate these 3 log lines that got captured and collected by Elastic. So we can see the 3 log lines. So now let's go ahead and plug the hole and see what's happening, what's going to happen next.
Cool,
over to you. Yeah.
Yeah, thanks, Michael. I'll just share my screen again. So back on Snyk here. So we know we need to fix something in our, we need to fix that issue in our vulnerable node app. So what I'm going to do is go back to this now. And what I'm going to do is, we know what it is. So it's a traversal. This is the issue, right, that we need to fix. And it was introduced through this library, st@024. And this problem is fixed in 025. So it's a really easy fix. We can just go to fix this vulnerability, which I'm going to open up here. And Snyk should go ahead and create a pull request for us. I'm just going to fix that one. All the issues are displayed here for this project, but I'm only going to be fixing that one. Shouldn't take too long. So one of the cool things about the fact that it's created this pull request directly on the repo itself is it's pulled in all the information that we know about the issue and made that available in the pull request here, as you can see, right? So the files that are changed are pretty straightforward. We know that we've changed the package.json from 024 to 025. And so what we can do now is, if we go back to this, I'm going to merge this. We also run some PR checks as well, right? So as a result of this pull request, the Snyk platform will actually go and run some PR checks to see if we're inadvertently introducing any new issues as a result of fixing this. So I'm going to merge this pull request. Confirm merge. That's cool. Now we know that inside our code base that has been fixed, but what we need to do is get this packaged up, put into a container, and then get redeployed on Kubernetes. So what I'm going to do now is I'm going to go to the file system here. Let me see where we are here. So to rebuild this, I'm just going to show you the script that I'm doing here. What I'm going to do is pull down the latest from the Git repo because I'm here on the file system here, so I get that fix. And then I'm going to do a Docker build tag and then go and push. I'm actually going to push a new image versus overriding the current image. And so Michael's going to roll out the new image and just make sure that what we were observing is no longer the case, right? So I'm going to say rebuild. So it's going to happily go do this. As you can imagine, it takes a little bit of time to recreate a Docker container with the now new patch source code that we did as a result of the Git pull. And so eventually, once it's gone and copied everything into the container, packaged it up, we're going to get a new container image file, and that is what Michael is going to roll out into the Kubernetes cluster, and nothing needs to happen on the Elastic side. It's already monitoring, so that's fine. Then we can run the test, I believe, Michael, to see whether or not the issue has been fixed as a result of this fix. So it shouldn't take too long. I can let this run in the background, and once it's created the container, then we can just roll out the fix. What I wanted to show those before we go back is, while I was in here about to fix this issue, Michael was talking about the ability. Not only do we show exactly what the issue is, and this is exactly what Michael was showing in terms of how you exploit this vulnerability using a curl and then just using a couple of escape characters as he showed there. But this learn part here is what our customers use this for, is to what are the implications here if we don't go fix this, right? So Michael's already showed us the implications. He showed us on the cluster what we saw and what that enabled them to get access to the root file system just through our application. But the cool thing is we can go and try this out ourselves here, even before we've gone and deployed this application and gone and put it into a Kubernetes, into a container, and then run on Kubernetes. So that gives you the feel for, okay, this is what the implications are. Maybe we should be fixing this far sooner rather than just leaving it as we've seen in this scenario here. So that's the Snyk learn thing. This issue now should be have been patched for us now. So might just need a bit more time, Michael. The world of Docker and images, and yeah, even though they use layers, they still take a while to rebuild, right?
That's all right. That's all right. Yeah. Probably the streaming video from your side is probably at play as well if it's trying to upload it.
Yeah. Anyway, so I can let you know once that's ready. If we go now and we go back to projects here, this should have been fixed now. So let's just have a look at whether or not it's done a new scan or not. So, and you'll see that traversal issue does not exist anymore. The reason it doesn't exist is we moved from one version to another and fixed it. So there is no, that vulnerability itself doesn't exist. We still have vulnerabilities, many more that we haven't fixed in the package.json, but now it's disappeared. So we can safely assume when Michael does his test that the new Docker image has the new source code that he's using now, the correct version that doesn't have the vulnerability, and so we safely assume that we won't have this problem again. So I think we're nearly there. Michael, this is the part that I wish we could fast forward, but because we're doing a live meetup, yeah, we can't do some funky video sort of stuff, right? So
Yeah, we've got time.
I'm going to stop sharing though, in case you want to just
Right.
show a few more bits and pieces, and I'll let you know once this is ready, right? So
Okay. I'll share my screen. So we're basically seeing three evidence of three successful exploitation attempts.
Sorry, Michael,
right?
some good news. The container is now ready. So when you're ready to release the new fixed container, you can go ahead and do that. Sorry to interrupt.
Yeah. So I'll just go on. So basically, I'll just go and do a goof apply, and it's now basically updating. Now the what I was going to show is before we just jump into or maybe let's see the logs now. So everything is running now. So I think that's got updated. Let me run my curl command. Here's my curl. I just wanted to add -v. So that actually shows me what it gets getting back. Now it's getting 404 not found. Let me run a couple more. So it gives me 404 not found, which is the right thing I expect. I expect my package to stop directory traversals. So in this case, 404 is good. So 200 is bad. 404 is good. So this is actually, well, we immediately, because we're streaming the logs, you can see my 404 is actually starting to flow into the cluster. So I can see my successful attempts that give me 200, and then unsuccessful attempts that do 404. And this is actually what I want to see. I don't want to see any successful exploitations happening for that particular directory. Again, if we want to ensure that we basically close the gap, we can go into the visualize library, build another lens visualization. I'll just show you how to do something more graphical than just simple table. So we can again drag the number of records. Right, we've got the filtering expression carried forward. These are our overall occurrences of basically someone searching for %2e in the original string in the Apache.access data set. And then we can split it by, say, response status code. So we can search for status code. I don't have to remember. I just here we go. We're going to say breakdown by. So we quickly can break it down, and we want to see those are going to be top values. So it takes them as values, not as numeric values. So here we go. We want to see the blue ones. So we don't want to see any green ones. We don't want to see any 200s. So let's just zoom back into the last 15 minutes. Right, so we had our three occurrences of, this is our three occurrences of 200s. We plugged the vulnerability, now it's 400s. Go and run a couple of more curls. 1, 2, 3, 4, 5. And hopefully now it's actually starting to look a bit more positive for us, because this particular vulnerability would have been remediated. Now, also to auto refresh, say every 5 seconds. Here we go. So here's 5 more attempts actually starting to flow through. So it's 6 seconds. Not too bad. So here's the new, we plugged the vulnerability now, right? So we're not getting any 200s, which is basically yeah. So this is what we want to achieve.
I just wanted to highlight something, Michael. So yeah, and we've fixed it. That's great. So one of the benefits, though, is that you can see, Elastic gives us that observability capability to try and see what's happening, and all those logs over time show us that how long we've had this issue for. But ultimately now we're using the Snyk module and getting that data into the Elastic platform. We could be doing so much more with the data to fix these issues well before they're even exploitable, right? So if the issues haven't been fixed, if the data is sitting there in Elastic, we can start querying it and start saying, okay, these vulnerabilities we really need to fix ahead of time, right? So, and this is an example of where an app's running in Kubernetes, but with the Snyk platform, we could have scanned the container itself and made sure the app wasn't even rolled out into Kubernetes because we saw the vulnerability in the container image itself, because we can also scan the open source dependencies that were brought in from the artifact, which was a Node.js application here, right? So I'm just giving you, allowing you guys to understand that what Elastic can do with its observability around Kubernetes is great, because that over time we saw exactly what this issue meant. But we also, now we've got the data in the Elastic platform, we can do a lot more as to trying to avoid any of these issues or others well before, 90 days or however long it's taken for this issue to surface. Does that make sense?
Yeah. So I was going to say, we can quickly turn this particular view to say, hey, which paths were exposed, which were exploited, so we can actually go and check out the files, for example. So we can say, hey, give me all the 200s. All right, so this is now my historical 200 attempts. And now I'm going to add an additional breakdown. So instead of 200 attempts, I'm going to get rid of the breakdown by the category, but instead I'm going to look for URL dot path, right? So we can break it down by URL dot path. And here we can actually start seeing how many different paths were exposed, right? And this particular case was public ... But I think, it's easy to go and say, hey, give me 5 months. I don't know if we've got enough data for that, but it's easy to see, how far back it started to be exploited, zooming in a particular time range. So let's say if we're exploiting a different path, then we can go and have a look at what were the sort of different URLs and which files may have been accessed from using that particular vulnerability. So really cool way to threat hunt once your data is all parsed and structured and indexed. So you get your responses really quickly.
That was it from our demo, yeah?
Yeah, I think that was it. Was there let's open up for questions. Do we have any questions? Do we have anyone? So anything you wanted to add?
Appreciate your time, Michael. It was fun.
Yeah, lots of fun. Awesome. All right. Everyone, thank you so much for your time today. And obviously the recording will be available if you're watching and you weren't able to attend it, reach out to us somehow on LinkedIn. I think you'll know how to find us. Other than that, everybody have a great rest of the day, and